तो माइक कैसे ऑन रहेगा?
चलिए, till there is some glitch with the presentation. Let me just start. We are now in the second session, and uh, some people were asking here about CSE. So we had put a few slides about what CSE is, those who don't know about CSE work. But before I do that, I would like to just say that this water, Sushmita has discussed the issues of water conservation, why we are here, what are the various challenges, all that everybody knows. So I don't need to repeat those things. What is important is that what hurdles and challenges we are facing today and what we are handling. So my esteemed presenters and panelists will share all that. So that also I am not, discussing. The important thing for us is what perspective we have. And because challenges are many, so some work at a micro perspective, some at a macro perspective. So building a perspective of what is required is also equally important. Now, building a perspective requires some ideological underpinning. What is your priority? Why you're doing that? Otherwise, it's like the elephant. Everybody touches the elephant from different sides and says, "हम ये कर रहे हैं, हम वो कर रहे हैं, हम ऐसे कर रहे हैं, हम ये नहीं कर रहे हैं." So I think building a perspective is a core of any serious work in water and sanitation. And for us at CSC, the perspective is two-pronged. One, it is a circular economy. Our belief that what we are doing is not promoting a treatment system, promoting a water conservation measure, promoting, a stormwater management solution. No. For us, the aim why we are doing it is the circular economy, because we believe if we don't do this, the nutrient and water cycles are mixing and water is also getting polluted, the nutrient is also getting lost. So that is the first why we do it. How we do it doesn't matter. You can do it through 100 ways. The second priority for us is people and livelihoods. Whatever we do, we keep that in the center. We are not talking of the excellence of one treatment system, the beauty of, lake rejuvenation. No, for us, the perspective is circular economy and people and livelihoods. If we have to do river rejuvenation, lake rejuvenation, it has to do with who benefits from it, not just because, BOD and COD levels have improved. That's why we are doing it now. And then how we do it can vary depending upon each person's capacity. Somebody teaching in a university like Mr. Professor Gosain will talk about science and scientific aspects. People talking on the grassroots, working on the grassroots will share their people's perspective, and CSC works in the middle. So we try to combine knowledge through different sources, both from the ground as well as from the scientific experts. CSC doesn't implement projects. So this convention for us is therefore important for us to share what we have done in the last 1 year. We normally do this every year and in the month of February, March, but given the elections, this time we preponed it. Earlier, we had planned this to happen in Uttar Pradesh, where one of our teams is working. We had planned it to happen there, but then for some reason it got cancelled. So we are having it here. So the idea is not just to share our lessons and our work, but also to get inputs from this group on what should be CSC's priorities for research and capacity building. So please keep that also in mind while you input on what presentations are made here. You also, highlight some of the priorities which are there, which CSC or any other organizations can do. So like I remember once I was with in the UP program with the secretary, he said, working in water sector, water sanitation, he said, we are evaluated every day. We are as good as we were 24 hours before. Agar pani band ho gaya, then we are bad. If sanitation ka issue aaya, people say they are not working. So I think what defines CSC also. So we don't, of course, are not in that position, unenvious position as the implementers at the city level. But we are also evaluated for what do we do. And if we just say that we support, that is a good thing. But then what else? So if you just bear with me, these are some of our publications which are there outside. And each one of these justifies what we do and what we should be objectively evaluated for, because these are all public documents. These are not private. These can be downloaded from our this thing. This is all the publications, and there are many others which we haven't brought here today. All what CSE has done in the last 1 year. So this is why we are here. We would like to you to also learn from the panelists and experts who are not CSE who are presenting here, and also to get your inputs about the water program briefly. CSC, I will not read this. You can see on the board, it was set up in the 80s when a lot of professional NGOs were set up in India. I also started working in 88, 89, and I was with Society for Promotion of Wasteland Development. That is the time when PRIA, CSC, Development Alternatives, SPWD, these were the four professional NGOs in Delhi. And then, after that, we have had a set of other professional NGOs coming up. This is the kind of work CSC is doing, because some people were asking, what is CSC? So is it only the water program? No. CSC has air pollution, climate change, industry, environment. We have a set of programs in which water, wastewater, sanitation is one of the programs. And the biggest team of CSC is in the communications part. So our communications team, which brings out down to earth, which is the most recognized face of CSC bi-monthly, plus a state of environment of India, an annual. And this year we also produced a state of Africa report. So this is our, I would say our origin of CSC. It is in the communications media side, education, training, and then comes the programs. So CSE doesn't implement any projects. We don't implement projects. We do capacity building research. We don't do watershed development, or we don't do steel industry boiler experiments. We don't do that, but we engage in that. This is how we are organized in the water program. We have urban program. It was actually an old slide, but it has now been merged. But then we have water, wastewater, and a UP team. And in the UP team, we have my colleagues are here from Bijnor and Chunar, and we work on these issues of state level. So I will not go beyond this. This is the kind of work which we do also have this international outreach program. So CSE's water program also works at an international level. And our aim is to take the lessons from India to the global south. And one of the publications here is this global south conclave, which we have shared with you. So with these words, I would like to just end, because this was an introduction about what CSE does. And now I would like to introduce the panelists. But in the panelist, I would like to introduce Rajiv Ranjanji. And Rajiv ji was instrumental when the MMCG CSE collaboration happened 3 years ago. This is the last year. That time, Rajiv ji was the head of NMCG. He was leading NMCG, and he realized, or rather, I would say, we were happy that he appreciated the need for a water perspective in NMCG. Like we had Ashok Kumar ji in the morning session, and he told you how NMCG was totally focused on STPs and sewage and preventing Ganga pollution. But under Rajiv ji's leadership, there was also this realization we must look at water beyond sanitation. So Rajiv ji and was instrumental in this program coming up, and we are very happy that in the last year we are again having him back, and to have him as a moderator for this session. Without taking more time, I would like Rajiv ji to lead it, to introduce Gosayan ji and other panelists, and Himanshu is not here but is there. Thank you, sir.
Thank you. Hello. Yeah. Thank you, Dipender, and good morning to everyone. A very warm welcome to the experts on the dais who are going to enlighten us with their work. before we introduce them and start the process, I think the structure is very nice. I mean, the four topics. I think we are going to talk about aquifers at the city level, and I think, see, it's very difficult to control water. It flows, whether a village comes in its way or a town comes in its way. For our own convenience, we talk about the urban area sometimes, sometimes basin, sometimes something else. So today, perhaps we are more focused upon this water sensitive planning, urban design, climate resilient cities. I mean, you can name several things, but focus is more on the urban area. So I think today we are going to talk to listen from the experts about how to do aquifer planning at the city level. We are also going to know about a little more in depth about managing lakes and water bodies to augment groundwater. So I think again focus comes back to groundwater. So how we link lakes with the health of the groundwater. So I think that focus again comes, and then Professor Gosai will be taking us to again storm water, and then how you manage storm water. Stormwater should not be just looked as a negative thing which is causing flood and we must get rid of it, but how stormwater can also be managed to actually recharge your water potential, etc., etc. And then I think one of the panelists is going to Mr. Pradeep Misra is going to tell us about some specific challenges in the Ganga Basin towns. When we had sanctioned this project, naturally the idea, because NMC's reduction goes in the Ganga Basin, so focus was on the Ganga towns, and I will be very happy to see some specific results coming out of it. But idea was very clear. Whatever we do here should have a kind of potential for sharing the learning to the other parts of the country and even beyond. So I think lots of things which we are discussing is not just Ganga Basin focused, but it's a kind of general thing, and I'm quite happy that CSE has done that. So I think we I will just, before I request the experts, just to give you, I told you that water is one. I mean, water does not see the boundaries. So water is one. So when we were looking at in NMCG about water, and when we were looking at the basin level, and Professor Gosai, I have association with him right from 2013 when I joined secretary in Ministry of Environment, and they were working on Ganga River Basin Management Plan. So I think that's the time we have been associated. And when he will speak, I will tell something more about him. But my association goes for almost now more than 10 years with him, and we worked together, developed that GRBMP. That GRBMP was one of the first of its kind exercise, which really helped me when I was joint secretary and when Namami Gange was announced. So that was the time I at the JS level we were formulating the contours of Namami Gange mission, and this was very good document because some sort of integrated approach came, going beyond just pollution control. I think many of you would have known when you talk of the river, we talk about Aviral Dhara, Nirmal Dhara, so unpolluted flow or continuous flow. And then we also basically talk about flow and ecology. So ecological development and how you can also improve ecology of the river and go beyond cleaning basically. And then the last thing which comes is you have to bring people in the whole narrative. Otherwise, who will ultimately do this cleaning? Who will do ecological rejuvenation? So I think people river connect and people this thing. From that, we developed, as we moved on, we also started feeling that the urban areas actually brings the maximum problem to the rivers and water bodies or water sources, even groundwater. So I think why don't we also focus upon managing urban river as a kind of more specialized thing, and that is where National Institute of Urban Affairs, CSE, many other organizations became partner of NMCG, and then they started working on that. When we say urban rivers, I will qualify as it has been given in the GRBMP. Also, the river does not make just a river flowing from point A to Z. Rather, it's something, its entire ecosystem becomes very important. So I think the urban wetlands, water bodies, I think they all become part of the river. So when we started talking about river, we started talking about the entire ecosystem. And that's where, if you look at the urban river management plan, which NIU has been doing, or urban river, I think there is one very clear agenda about groundwater, floodplains, aquifers, and also water bodies. So they are all very much component of that whole management. And so it's very good. Again, when we talk of the groundwater, there is a huge priority given by the government right from 2019, especially on the water sector. Jal Shakti Abhiyan. catch the rain. So I think all these things actually is trying to sensitize people to do something. Again, if you look at the kind of much larger level, then the NAQUIM, the National Project on Aquifer Management, NAQUIM came. I think lots of mapping exercise has started going, how to go for a better map, better mapping of the aquifers, etc. happened. Atal Bhujal Yojana is there, which the approach is also to bring community, bring the stakeholder into the picture. And then the Amrut 2.0 mission very clearly also focuses upon shallow aquifer management. So I think there is a some sort of 10 cities have been taken up under shallow aquifer management program, where a kind of pilot program is happening. And I think Mr. Kulkarni will join. So I think Mr. Kulkarni is also helping NIUA in that program, Cellular Aquifer Management Program, which actually goes into details of basically how to train, how to build the capacity of the urban local bodies about shallow aquifer management. I mean, the mapping of the aquifers. And it goes through a kind of simple step-by-step process where actually they can all go about city level assessment and mapping, trying to build your database, and then trying to find out different, the appropriate recharge strategy, what should be the recharge strategy, and in that also become to some of the surface water, some of the lakes, etc., that how they can be part of this kind of strategy. So I think that's the kind of thing. So without taking much time, I think a stage is set now with this background to invite Professor TV Ramchandra. He is from Center for Ecological Sciences, Indian Institute of Sciences, Bangalore. uh, he is a very senior expert, and he combines his expertise in the field of energy, wetlands. He is in fact heading, coordinating energy and wetland research group there. He is convener of information system at his center, and he is specialized into energy, renewable energy, ecological aspects, energy planning, ecological modeling, wetland, soil and water pollution, bioremediation, solid waste, etc. I think I don't want to go into the details of the papers and books, but he has to his credit numerous research papers and book chapters, and guiding students and other stakeholders in with his rich work. So, Professor Ramchandra, please uh, share your thoughts. Okay.
Yeah, good afternoon to everyone. So I have come from Bangalore. Once upon a time, land of lakes. Myself and Vishwanath are here today. They're talking about Bangalore.
Yeah.
I will talk about at the ground level, while I think Vishwanath will touch upon the policy issues. Now, why do we need wetlands or water bodies? One, I understood, if there is a water, if there are wetlands, water security is ensured. For water security is there, then food security will be there. And also, if the wetland is clean, pristine, there's health, and there is a resource availability for everyone. Every statement I am going to quantify with time. And services provided by this ecosystem can sustain the livelihood of the people. And when there are abundant resources, there will be happiness among everyone. Okay. And also, the wetlands are resilient to changes in the climate. If this has to happen, a wetland has to function, then we need to manage. For that, you need to maintain the ecosystem integrity so that you will have ecological security and the adaptation to the changes in climate. I thought that best thing is to give the science to the society and policymakers. Recently, we launched the decision support system, which is available online. The work what I did for the last 2.5 decades, all my data, my students' data, I have made it public. You can visualize the lake in Bangalore. What is the water quality? What is the kind of species of algae, zooplankton, fish are there? What is the ecosystem services? And how much of the wetland is encroached? Except who has encroached, I have not put. Because I want to live for slightly longer time. So I thought I should not put that. I have that details also. Okay, now let's look at the lakes of Bangalore. In 1800, there were 452 water bodies were there. The city of Bangalore today is 740 square kilometer. we had 1,452 water bodies and about 80% green cover. Because of that, temperature in the region during May month, summer month, was 14 to 16 degrees Celsius. And for a few days in December, the temperature was 0 degrees Celsius. And we used to grow apples in place called Palace Archer, very close to my institute. And today, number of water bodies has come down to 193. Vegetation cover has come down to 4%, less than 4%. And temperature is 34 to 37 degrees. We have many achievements. One of the greatest achievement of Bangaloreans is doubling the temperature. So the city, which was a garden city in 70s, became a garbage city. Now it is a dead city. And when you look at the lakes of Bangalore, it is an interconnected lake system. The river was passing through the region. Our elders just put the bund and made it a water body so that it can meet the requirement of irrigation and domestic water requirement. And today you look at the situation, lakes are not interconnected. Thanks to the very influential section of the society. See, when you encroach lake, you become very powerful. Then you will also become a film hero or the politician. These are all the additional qualification one should have to become a politician. Now, earlier when the lake was constructed, any ruler used to design the town, used to have a protected wall and the water body. That means the water security was one of the agenda of the rulers. Today, we have 193 water bodies. Wherever people look at the lake, they think of Lakeview apartments. Okay. So now, let us look at the water cycle. The groundwater recharge is one of the important part of the water cycle where infiltration is the process which facilitates the thing. That is where the cover of native species of green will always help in the infiltration. My study shows wherever native species are there, about 60% of the rainfall get infiltrated to the groundwater zone and vado zone. And riparian vegetation that are on the shoulders of the water body or in the buffer region or in the floodplain helps in the remediation. That means treatment of the water. So that's how we used to have the clean and adequate water. Okay. Now, let's look at when the lake is removed, what happened. When the water body was removed in early 2000, earlier water table was 80 to 100 feet. Gradually, over the last 23 years, it has gone up to 1,900 feet. 1,900 feet we have gone deep, but there's no water. But the same Bangaloreans, we are searching for water in moon. We did Chandrayaan also recently. Okay. And we have done the concretization of the city so much, the groundwater table has gone down to 1,400 to 1,900 feet. People are struggling for water. 45% of Bangaloreans depend on the groundwater. Now, you might ask the question, what is the proof of the linkage? When we rejuvenate the lake, we saw the improvement in groundwater. Had there is no linkage, then how you would have noticed? So because sometimes the urban experts, there are some urban experts in Bangalore who say that lakes are not required in Bangalore. I always tell them, you drink water. That water comes from the lake. You have to accept that. So, Saraki Lake, which was about surrounding area, 920 feet groundwater. Today, it's about 610 feet. Okay. Then let us look at the other services provided by the lake to the urbanites. It gives when the lake is a clean state, like Rachinalli or Jakkur Lake, it gives about 10,500 rupees per day per hectare. When you pollute the lake, the worth of the lake come down to 20 rupees per day per hectare. Who are the people who depend on the lake? Fishermen, washerwomen, agriculturists, other one depend on the lake. Who are the people pollute the thing? Elites like us who sit on the other part of the city. We pollute the system. And that's where livelihood of the local people get affected. The worth come down to 20 rupees per day per hectare. Now, let us see what is the ecosystem services provided. We try to look at the provisioning, regulating, and cultural services. And we did the study for all the lakes in Karnataka. We looked at what is the per hectare values. I published this article in the Terry magazine, Terry journal, and it's available online also. A lake is worth 1 million rupees per hectare per year. That is the worth of the lake, which include the provisioning, regulating, and cultural services. So now if there are 39,000 water bodies in Karnataka, what is the worth of that, those lakes? It amounts to about 284 billion rupees per year. Okay. If you look at the net present value, the asset value, it comes to 7,320 billion rupees is the worth of the lakes in Karnataka. Why I'm putting this number? If somebody encroaches, you should know how much the worth of the lake they have encroached. Why the bureaucracy and judiciary is keeping quiet on that? Okay. Now let's understand how the catchment integrity helps in the livelihood of the people. We did a study to understand how much water get infiltrated in the underlying layer when it rains. This is an experiment of 3 years covering the all seasons, and also we wanted to account year-to-year variability. When a catchment has a native species vegetation, because of the diversity, the soil microorganisms also are diverse and abundant. When soil organisms are abundant and diverse, it makes the soil porous or permeable. When the soil becomes porous or permeable, it allows the water to percolate. It fills the zone, which is a groundwater zone, then the vado zone. Then only after saturation of these two layers, you will see the water flowing in the lake or in the stream. Now, if the region is converted into urban area, like urban system, nothing gets inside. You have floods, you have the water scarcity during the post-monsoon. So now you might ask how the livelihood of the people are dependent. Wherever lakes are there, if we see that earning in the rural area is about 1,54,000 rupees per acre per year, because they can grow multiple crops because of the water availability throughout the year, where people have converted into the monoculture plantation in the catchment area or the urbanization in the catchment area, they can grow only one crop because the water is available only during the monsoon, and they can earn only 32,000 rupees per acre per year. And more importantly, if you look at the yield of the crop in the vicinity of the catchment dominated by native species is as high as 12 to 18 quintal per acre, the paddy, whereas the yield of the paddy in the degraded catchment is about 8 quintal per acre, 6 to 8 quintal per acre. That's mainly because when native species vegetations are there, the pollinators are abundant, and the pollinators include bees, honeybees, the butterflies, etc. Pollination become efficient. When pollination become efficient, yield is higher. The government of India wants to double the income of the farmers. I would say just maintain the ecosystem integrity. The nature gives the water. The farmers get their yield, and they can grow multiple crops, so that doubling the income happens without much expenditure. If we don't take care of the thing, what will happen? Let us learn from the history. Easter Island, people thought land is available. They went on expanding the land, the city like Bangalore, Bruhat Bangalore. But one day they have to vacate the island because there was a water scarcity. Similarly, last leg of Vijayanagara kingdom failed because of the water scarcity. These are the lessons we need to learn and make sure that our children don't face the water crisis. Now, what are the threats to the wetlands or the lakes in Bangalore? The same thing happens in Hyderabad, Chennai, the Mumbai, etc. Look at the way the concretization has happened. 68% green cover in 70s when I was a kid, and today 86% is concretized. 33% green cover in the region for a city to be livable. The criteria we didn't meet. So that is the kind of the thing that's happening. All these things I have put it in our information system. Then I also thought that people who urbanize don't look at our website if it is only the lake information system. Then I created another website, which is a Bangalore Urban Information System. So that is where we have put all the things, all the infrastructure, the amenities, the sewage generated, ward level, all the details we have put it at this one. So that my hope is that when the information is available, the decision making might be more effective. Earlier, the decision making may be erroneous because of lack of data or the information. I'm hoping that at least my next generation will have the benefit of better management. And number of lakes which are lost in the region, we have lost about 79% of the water body post 1973. And 88% green cover with a 1,055% increase in concrete area. Consequence is temperature of the region is going up. 21% in 90s became 24 degrees Celsius in 2000, or 28 degrees Celsius in the 2010 became 34 to 37 degrees Celsius now. And if you look at from the center of the city in a direction, you see wherever lakes are there or the parks are there, temperatures are 2 degrees lower. Because this highlights that these ecosystem acts as the heat sink. They moderate the microclimate. Even my campus, you see that vegetation cover is as high as 54%. Because of that, we do good science. And when we mismanage the thing, you see that we have the floods happening. The Suresh Kumar talked about the flooding, the same situation everywhere. You know why floods happen? Because lakes are interconnected. When you remove the interconnectivity, that area becomes prone to the thing. Then another thing, people have a affinity toward the concrete. Even the lake bed or even the drain bed, they want to concretize it. Narrowing the drain and concretizing in the name of waterfront. I thought that waterfront give the recreation, but I don't know. Looking at the concrete thing, what recreation we will have. See, when you concretize the drain, hydrological function of the drain is lost. Earlier, water used to percolate, that is lost. Second thing is when they narrow the drain, they are making the city more and more vulnerable to the flooding. With the changes in climate, that's what Susmita talked about in the morning. There is a high intensity rainfall is happening in every region. And that means we need to design the drains, Rajakalway, so that it can handle it. We should not narrow down. But I didn't know that there is a money part involved in that. For every kilometer of remodeling of the drain, 8 crore is spent. That is why people have the affinity towards concretizing the drain, which is the tragedy. Okay. Now, other things happening in the city of Bangalore is lakes are used for dumping solid waste. If nobody notices, Lakeview apartments come. And those who are, the lake receives untreated sewage. The Belandur lake was receiving about 500 million liters of untreated sewage. When the lake was clean, it looks like this. When the lake is contaminated with a nutrient enrichment, it had a profuse growth of macrophyte. When there is a profuse growth of macrophyte, sunlight doesn't penetrate. In absence of sunlight, you will not have the algae. Because algae is not there, zooplankton will not be there, and fish is not there. That's where the worth of the lake come down to 20 rupees per day per hectare from 1,050 rupee per day per hectare. The glory of Bangalore is frothing lake. I know there are Yamuna is also here frothing. And the fire in the lake. I have visited many countries. Nobody has shown me the coexistence of fire and water, but only my city, Bangaloreans have shown me that. And what is the solution? We have been talking, myself, Vishwanath talking about phosphorus problem in the lake, and that has to be removed. We need to treat the sewage and industrial effluent. But what our decision maker does, because the froth was coming to the road and international media was capturing it, they wanted to stop that. They put the barricade. They claim that they have done the job. I said that this is a ad hoc. The solution is not going to solve the problem. Within 4 days, you will see the same problem. But the decision maker didn't agree with me. But the froth crossed over on the 5th day, as I predicted. And in the process, they had spent 2 crores. When you spend 2 crores, you know how much money a wallet gets filled? Okay. And what is the other problem of mismanagement? This is narrowing the drain. You see, earlier drain was 80 meter. Today, it is about 18 meter. Not only concretization gives the money, even with the understanding with the builder, we get additional money here. So that's where the problem is. The mismanagement of natural resources throughout the globe is the corruption, the sign of corruption. And the consequence of that, when the water bodies get contaminated, when water is used for growing the vegetable in the downstream, there are implications. We collected the fish from the lake and also the milk, the cattle milk in the surrounding area, and also the vegetable that is grown like pudina, spinach, radishes, etc. All of them had heavy metal. Then I was curious. I wanted to see what is the health implication. I was shocked. The kidney failure, which was 1 in 1 lakh about the 12 years back, today is 1 in 5,000. Because of that, every ward in city has the dialysis unit. And as far as the cancer is concerned, we are number 1 today. Okay. Then we push the government and push the judiciary to rejuvenate the lake. Of course, NGT gave a favorable thing. They penalized government of Karnataka 500 crore. They constitute a committee. I am also a member of the committee. Then the rejuvenation was taken up and we thought that desilting has to be done. We did a quantification of the silt accumulated. Then we found that 11 million cubic meter of the silt is accumulated. The moment I released this number, people started saying, oh, the TVR is going to create the traffic problem in Bangalore with the removal of silt moving in the silt. Then what did I do? I looked at the contamination in the silt. I found that Varto Lake doesn't have any contamination. Then I just had a meeting with the local farmers. We convinced the farmers to take the silt. 400 acres, we supplied the silt. After 4 months, when I visited the same region, I got the royal welcome. They invited me with a bumper crop. Each farmer tells me they got 1,50,000 rupees per acre in one season crop. They are going to think this is the value of the science getting into the society, and that is what should happen when scientists do the science. When you see the smile on the face of the farmers and Aam Aadmi, you feel satisfied. Okay, and they are going to grow 3 crops. That means 1.5 into 3 into 400 acre. You can see the worth of the silt and how people are benefited. That is what should happen in our country, because 65% are agrarian. We need to do the desilting of the lake, and that silt should be used to fertilize the soil in our agriculture field. Now, what else we have done? So I will take another 2-3 minutes. Anyway, I have not passed the limit. 15 minutes is the allocated time. So the wastewater treatment, constructed wetland with the algal pond. Okay. Then rainwater harvesting to make the water, to ensure water sustainability, and create mini forest in each ward or in each village to ensure the water is available and the groundwater recharge happen. But all these things to happen, we need to sensitize the people, sensitize the youth. When they become decision maker, at least I will have a new breed of decision maker. That is what we are trying to see through the environmental education program. If you look at Bangalore, the city of that receives about 700 to 850 millimeter rainfall. That means I have 15 TMC of water. 15 TMC of water, the Bangalore requires 18 TMC. That means 70% of the water available for Bangalorean is available in the form of rain. The best way to catch this rainwater to the rooftop harvesting, individual houses will have 3 to 4 months of additional water. The other best option is through the lake. You rejuvenate the lake, retain the rainwater in the thing. So your groundwater get recharged with the clean water. And other advantage is, if Bangalore is also using 18 TMC, we generate 18 TMC of wastewater. If I treat that through the constructed algal pond, I'll have 16 TMC of water. That means 15 TMC because of rainwater and 16 TMC because of the wastewater treatment. I have 31 TMC. But this can happen only if I have the 5R formula implemented. First R is a responsible citizen with the knowledge of environment. When people are responsible, they rejuvenate the lake. They will not allow the pollution of the lake, so that I can retain the rainwater. Then they will also allow the reuse and recycle of the wastewater. See, otherwise every Bangalorean asks, why do you want us to treated water, to drink the treated water? I always tell them, now Bangaloreans are drinking the water that comes from Mysore, which is polluted because of the Mysoreans. Instead of drinking that treated water of Mysorean, let us treat our own water and have it. That's the best option. So then how did what is the success model that is going to be replicated in Belandur Vartu? What we did in Jakkur Lake, which even our Vishwanath will highlight, way back in 2005, when I studied Jakkur Lake and surrounding bore wells, there was nitrate. Nitrate is a carcinogen. When they pushed the government to rejuvenate the lake, and when the lake was rejuvenated, they constituted a committee. Since I had cried, they put me in the committee. Then they said that they can give money only for a secondary treatment plant. Secondary treatment plant will remove only the chemical ion, not the nutrient. Then what I did was I just integrated constructed wetland and algal pond. And we monitored this lake for the last 12 years. This report is available online. About 85 to 90% nutrient removal happens. This is one of the famous success story of the Bangalore, which the Globe also comes and, global scientists come and students come and visit that location. What else have we done? Wherever possible, we created a water body at my home, in my campus, created a water body in the campus, which becomes a perfect, the lab for my student to do the water research, water quality research. So, and biofuel research. Not only students are happy, I'm surprised I have also otter. From where it has come, I don't know. Otter is there. The pair of otters are there. If otter is there, there has to be a enough fish in the lake, which I don't go and feed the fish every day to the otter. So when we did the biodiversity documentation, we were surprised to see nature has created the system which provide the food for all the biotic elements that thrive there. And also when I meet people, we make sure they create the water body. This saint was worried because his taluk was facing the water crisis for the 2 year 2014-15. When he invited me 2016, I gave a proposal to create a water body after doing the study. Then within a 10 or 15 days, he created the water body with the local youth. And also I asked him to take up the desilting of the lake in the region. He did 2 lakes desilting. Because he did 2 lakes, the remaining 30 lakes in the taluk were desilted by his followers. You know, last year, again, there was the scanty rainfall in the region, but this particular taluk didn't face the water crisis because of this kind of the measures. Now, after seeing the success, I found that one of the education institution students were involved, and CEO is also quite young. Then I gave him a medicine to create a water body in his campus, you know, with the native species in the surrounding area. You know, after next year when I visited, I see a greenery with abundant water. You know, that is the kind of thing. If you want to have happiness, you need to have a greenery in the surrounding with abundant resources. And to put it on the lighter side, the CEO, when he met me, he was alone, the bachelor. But after creating water body within 6 months, he gets a wonderful partner who take care of the joint family. This is the message to the youngster. You want a good partner, want to be healthy, do this kind of work so that your family life would be healthy. Otherwise, searching on the Facebook, all faceless fellows search on the Facebook and then within a week they file the divorce paper. Okay. Then if you come to the campus, you know, you will see this climber. This climber, I was fascinated. It was from the Western Ghat. I felt I should have it in the campus. I got that pot to the campus. The 14 seeds were there. 7 I planted in 7 locations. Out of 7 locations, only 1 place it has survived. Other 7 seeds I have kept in my room so that if somebody says, what is the fruit? They can do the molecular study. So then out of 7, only 1 survived. That is next to the building where I have worked for last 2 decades. That means even the plants know who will take care. In front of the building, I created a mini forest in a 2-hectare area. 49 native species, 500 saplings were planted way back there in the 90s when I was a student. Today, you look at that region, you get a feel of the rainforest with abundant biodiversity. You can see slender loris. If you are very lucky, you can also touch snakes in the region. Groundwater table, which was 150, has come down to 9 to 10 feet, and temperature has come down to 2 degrees lower. And now the last part, 1 or 2 slides are there. The environment education, you can see that. And also we do the capacity building through the environment management program. We have been offering this certificate course for the last 20 years. Okay. And we conduct the symposium, popularly known as Lake Symposium, once in 2 years. You know, from 98, we have been doing 13 events. We did it. Now it's an international event. About 1,000 people participate, the international national expert. And the uniqueness is the school student and college student do that. They do the
Kindly conclude.
yeah, I'm this. And then the catchment mapping and water quality assessment, they do that. Okay. So this is the glimpse of this is the announcement of the Lake Symposium, which is in October. You are most welcome to take part. So, and if you need more detail, these are the portal where we have put all our publications, my YouTube talk, everything is available. So you can see the PDF of my publications are available. And recently our initiative also led to the designating one of the wetland in Karnataka as the Ramsar wetland. Earlier people said there are no Ramsar wetland in Karnataka. So we have been successful. See, my agenda was to sow the seeds of knowledge in the youngster here. They become the responsible citizen for the country. They will be an asset to the nation. That's what we should do. Thank you very much.
Thank you. Thank you so much, Professor, for really a presentation which was very thought-provoking. The key word is maintain ecosystem integrity, interconnected wetland. Actually, the key is if we allow nature to help us, lot of our problem will be solved. But unfortunately, as he said, our great love for concretization takes away all those love for nature. So I think we will not get more into that. But the presentation was great and it brings the whole thing so much in focus. As time is a little limited, I will request all the experts to limit to 15 minutes. I think now even with 15 minutes, we'll be finding difficult to get time for the questions. So let's be little quick. I now request Dr. Himanshu Kulkarni. He will be joining us online. He is founder, trustee, and scientist emeritus from Advanced Center for Water Resource Development and Management. Again, I had the benefit of working with him in different places and learning from his deep knowledge about aquifers. Apart from the hydrology and scientific knowledge, his work also brings community close to the work. I mean, as Professor has told that you have to go to the students, you have to go to the community. So similarly, his work also brings community to the aquifers, and uh, he has also been helping. I talked about the shallow aquifer management program under Amrut. So he has also been mentoring National Institute of Urban Affairs in developing that program guidelines and improving the lot in some of the pilot cities. So can we have Professor Kulkarni? Someone has to connect him.
No, I'm here. I'm
Okay.
here.
Yeah. Okay. Okay. Thank you. Welcome. Welcome. How are you, sir? Please go ahead.
I'm okay. I'm sort of good enough to make the presentation. I'm afraid I must apologize. I couldn't come there. I took
Okay.
ill yesterday, but I'm okay today. So hopefully I'll be able to finish in 15 minutes. I'll try my best. Let me share my screen. I'll probably stop my video just to make the bandwidth fine. Uh, is it visible?
Yeah, we can see it.
Yes, okay. So let me jump straight into the presentation. And I want to begin by, first of all, thanking CSE and Namami Gange for inviting me. And also begin by saying that we are, in this session, probably going to look at water bodies, lakes, rivers, aquifers, and perhaps struggle with the dilemma of these water bodies as sources and sinks. As Professor Ramchandra elucidated very nicely, just the sort of two functions of water and water bodies as sources and sinks. So I'm actually going to focus on urban aquifer systems, especially with regard to the source and sink in conservation. So let me begin. By saying that at least half of urban water usage in India is groundwater based. We don't necessarily see it, we don't necessarily acknowledge it. This means India's towns and cities use nearly 14 billion cubic meters of groundwater each year. And it comes from various sources, it comes in various forms. It doesn't necessarily become visible even when we use it. Now, I think we have to look at this in the backdrop of what is happening at the global level. India's intensity of groundwater extraction is one of the highest in the world. I would say it's the highest in the world. But what is interesting is we, I think given that the urban extraction of groundwater doesn't necessarily get formally counted, we could be hitting something like 300 billion cubic meters annually, the annual extraction. A lot of the rural, the agriculture, the industrial also gets counted. But I don't think the urban is actually getting counted. So with 300 billion cubic meters, and as sort of compared to that, as compared to the global extraction, which is 1,000 billion cubic meters, we are at 30% of the global annual extraction. Now, what is even more interesting is, especially in urban India, this extraction is happening from a wide range of aquifers, from a wide spectrum of aquifers. And I think some years back, we developed this typology of very broad typology of aquifer systems in India. And we found that urban habitations, urban sort of cities and towns actually get distributed across these aquifer systems. So it has a wide representation of aquifer systems. And because these aquifer systems, each aquifer system is unique, let me sort of push this down here, is unique in its character, whether it's the storage of groundwater, its transmission capacities, and quality, of course. We are actually dealing with a very complex sort of a system in our cities and towns. So on another front, we can actually look at it from another dimension, from another side. And this actually means that aquifer systems also define the distribution of differently sized towns and cities. So if you look at mountain aquifers, whether they are in the Western Ghats, if you look at aquifers in the Himalayan system, then the nature of the urban landscape, the nature of the growth of urban in India also changes, is also very different. Of course, topography, land use, land cover are important. But the underlying aquifer system many a times defines how urban growth occurs. Let's go to the next one. Now, where are we at the moment? So at the moment, what are we trying to do? And what we are trying to do is to close the loop in urban India, especially by bringing in reuse of water, recharge of groundwater, and recycling of wastewater. Now, in a linear system that was very nicely defined by Professor Ramchandran, and I'm sure my friend Ashwini is actually going to talk more about this. When we actually look at this system at the moment, it's a very, very linear system where fresh water comes into the urban habitation, it gets consumed, wastewater gets generated, then there are water bodies, usually rivers and aquifers, which are also coming into use. And then we sort of pass on, whether it's fresh water or used water, to downstream users. Now, like I said before, an aquifer is actually something that comes into the system from the side. I mean, laterally, in some ways from the bottom. It's a kind of a bottom-up axis. Now, if we bring in retreated wastewater, and like what Bangalore is trying to do, and like what many other cities are trying to emulate, so treated wastewater is one loop. Treated wastewater for aquifer recharge, for groundwater recharge, and of course, in the larger context, reuse of wastewater in supply. So these are nested loops. But I think one of the things we need to also understand is bring in the fourth R, which is to reduce our groundwater footprint. And I'm going to spend perhaps the next 7 or 8 minutes in trying to show you, in trying to sort of highlight some of the thoughts I have. Now, the mantra, therefore, when we talk of recharge and reuse, recharge and reduce, is where do we recharge and what do we reduce from? So the what is important. And the what is really the aquifer. Because recharge is the addition of groundwater to the existing storage in the aquifer. It's not recharge of groundwater anymore. I think we have to move from using the semantics of recharge to groundwater to recharge to aquifers, because then we'll actually be able to identify aquifers as systems, aquifers as resources, aquifers as entities, which are on par with watersheds and river basins and lakes. Now, the aquifer is also where extraction of groundwater is happening from the aquifer storage. So when we actually look at this whole system, recharge our aquifers and strategize our extraction must become the new mantra for how we look at water management in India, especially urban India. Now, while doing so, we must also understand that recharge in urban India, especially recharge in urban India, has three specific contexts or three specific dimensions. One is natural recharge to aquifers that occurs through infiltration of precipitation, either directly to land through the permeable rock formations, or at certain locations through the beds of streams, rivers, and lakes. This is going down. On the other hand, unintentional or incidental recharge due to man's activities also occurs because of the effects of land clearing, excess irrigation, leakage from water main sewers and storm drains. And this is very important. Now, what this does is it actually creates a zero-sum game of recharge in urban India, where we have declining natural recharge, but increase in incidental recharge. And I think this is where taking forth the concept of managed aquifer recharge becomes important. Because managed aquifer recharge describes the intentional storage and treatment of water in aquifers through a set of systematic interventions that are based on one, water that is available on the surface for recharge, the quality of water, the quantity of water, and the underlying aquifer conditions. So, I mean, this, for example, the left-hand side photograph is a photograph from Leh and Ladakh, which I use as an example of a very differently urbanizing center, and sort of also located in a very, very different environment. I think this is also happening in places like Leh in Ladakh and some of these sort of smaller and large towns in the Himalayan system. The lower diagram is a system that people in Pune, especially, with our interventions, our science, we were actually able to sort of develop different systems of managed aquifer recharge in the city of Pune. Now, we know that managed aquifer recharge actually have, through international guidelines, has three broad categories. One is it actually looks at spreading methods, and the second one is injection through injection boreholes. And these are broadly defined as diffused and point source managed aquifer recharge. And I think it's important for us to realize, where do we adopt the diffuse and the point source recharge? And a lot of this decision depends upon, first, realizing that managed aquifer recharge, especially in urban India, is not just pushing water into the ground. It has a system of different I would say it's a very diverse system. It's a typology of situations. And for example, if you are routing stormwater drain or sort of flood waters on the roads in urban India into a system, into an injection borehole, which is something that we are trying to do in a couple of places in Pune, you need to think about water quality. And I think it's important for us that aquifers, the provenance of recharge water, and the necessary system of filtration and intake become very important in this regard. Now, when I talk of aquifers, and especially when we talk of groundwater recharge, it's important to realize two things. The rate at which water will be accepted by the aquifer will depend upon one of the important aquifer properties, which is its transmissivity. The amount of water that will be accepted will depend on its storativity, and of course, the situation that the aquifer is in. If it's an overexploited aquifer, then you probably need a very different strategy. If it's not such an exploited aquifer and it's fairly in balance, you probably need a very different strategy. So I think recharge and extraction are two sides of the same coin from the aquifer. And it's important to realize that aquifer transmissivity, aquifer storativity, and the quality of groundwater in the aquifer becomes very important. Now, the other dimension of aquifers, while we talk of recharge, is we mustn't forget the natural aquifer discharge, or the discharge function of aquifers, the natural discharge function of aquifers, especially through springs. And I remember a conversation that I had with Mr. Rajiv Ranjan Mishra in his office when he was director there, on springs and how do we bring in springs into the work on Namami Gange. And it sort of takes us back to that conversation. So one of our efforts at Aquadam is to try and map urban springs. So in Pune, for example, we have been able to map about 63 springs, 63 perennial springs that feed groundwater into the river channels. And I think this becomes an important element to consider when we think of large projects like riverfront development. So recharge, discharge. Let me conclude with about 3 or 4 slides, and each is perhaps a challenge. I mean, the last one is perhaps a broad solution. I think one of the big elements that's actually happening in urban India is urbanization that leads to the loss of aquifer material. Because when we construct, whether it's infrastructure, whether it's building, whether it's housing, when we construct on the ground, we tend to excavate from the subsurface. Excavation of the subsurface, especially at such a large scale as happens in the urban context, actually means removing a lot of aquifer material. So the shrinking and modified aquifer space actually becomes an out of sight and out of mind issue in urban India. Flooding of basements and the drying up of old wells are classical examples of, are classical effects of such excavation, such sort of unmindful excavation. We simply don't have rules and regulations on excavation that leads to the impact on aquifers. Now, I think there's another thing we need to consider, and these are very 2 quick slides. Urban water footprint is something that we need to bring in using the density of people per unit of land. And this provides a very different dimension for comparison, especially with the rural space. And I think the rural-urban continuum is important. Rajiv, I'm just going to take 2 minutes if you don't mind. Is that okay?
Yeah, kindly conclude as quickly as possible. Yeah.
So if we look at 200 flats on 1 hectare, with 800 persons on 1 hectare at 150 liters per capita per day, this means 43,800 cubic meters per year. Now, if you actually look at this in terms of sort of millimeters of water, it's 4380 millimeters of water demand or water usage, which is equivalent to growing 2 crops of flood irrigated sugarcane in the rural space. So what we've also done is we've done some modeling in terms of comparing the density of people per hectare of land with the intensity of water required to support different crops. And I think this can actually be used in terms of how we plan and how we regulate our water, how we regulate our urban space. Okay, so comparing the urban and agriculture sectors on the basis of water footprint is interesting, and I'll say to say the least. I want to end with what all of this has led to in the city of Pune. I'm actually not talking of too much of technical stuff here. So we've produced a report on Pune's aquifers based on aquifer mapping. There's an entire set of water metrics in the report. There's planning. There's a whole section of interventions. But what is interesting, because as a part of this process, we partnered with the urban local body, the Pune Municipal Corporation, and we were able to develop something called a groundwater cell, which is now embedded in the urban local body, which is the PMC. It has many functions. I won't actually read all the functions, from mapping and information to actually using managed aquifer recharge and taking it to the concept of a public service, groundwater recharge or aquifer recharge as a public service in which different people can invest. There's sustainability, equity, efficiency, revival of wells, many, many issues. But I think what is most important is institutionalizing groundwater governance in Pune through the groundwater cell based on aquifer mapping, based on managed aquifer recharge plans, and of course, piloting of all that. And the groundwater cell in Pune, for example, is now functioning for more than a year. We have meetings every month, and a lot of what needs to be done, a lot of what gets done, actually gets discussed in these meetings. I'll stop with this slide. So, looking at aquifers, looking at recharge, the question is, how do we constitute an integration of managed aquifer recharge, groundwater management, and governance, groundwater governance at different scales, ranging from a simple structure like a recharge structure, watersheds, aquifers, and of course the large river basin context, which I'm sure my friend Ashwini is going to talk about. And I won't go reading into the details of all of this, but I'll say that the well, the large diameter well, and I'm sure Vishwanath is also going to touch upon this later. The large diameter well, the dug well, has actually sustained India for many, 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 many centuries or millennia. I can go on about talking. I can go on talking about this, but how do we bring the large diameter well? How do we bring the shallow aquifer back into the context of urban India? Just like we want to bring back the lakes, we want to bring back the rivers, and I think that will be a real tribute to the legacy of aquifers that the world has seen for many, many millennia. Thank you so very much.
Thank you so much, Dr. Kulkarni. It's always enlightening listening to you. So I think in a very clear way, he has told us the complexity and also what actually needs to be done, and then what are the different options. If we get time, we can discuss that. As we are running little short of time, I will now request Professor A.K. Gosai. He is Professor Emeritus from IIT Delhi, and then he had several hats to really support water resource engineering, ecological things, climate change related impact assessment on Indian water sources. And he is also part of several committees set up by National Green Tribunal and other courts, more specifically about Ganga and Yamuna floodplains. And we used to be part of the same committee looking at Yamuna floodplains for some time. So he's going to tell us about managing stormwater drainage in flood-prone cities. We have seen about the lakes and wetlands. We have gone into the literally into the depth of the aquifers, and then how groundwater needs to be managed in the city, a kind of balance between recharge and extraction. And now, when we are looking at the water cycle, the stormwater, that's important, and how to deal with that, and how that can actually help in mitigating flood, and also what kind of uses can be there out of the storm water. So I think over to Professor Gosai.
Thank you very much, Rajiv Ranjanji. My colleagues on the dais, Dr. Kulkarni, and ladies and gentlemen. I'll be basically focusing on the urban drainage systems. I'm focusing on this issue with respect to any city in general, but I'll be taking examples from the Delhi as a city. We had done some time ago the drainage master plan of Delhi, where we had tried to address the various issues which are facing Delhi. People just mentioned that every rain, Delhi gets flooded. So we thought that since we are sitting on Delhi as IIT, we extended our helping hand to the government of Delhi, and we said we'll study the issues in a very scientific manner. I'm going to share with you that how this needs to be handled in every other city and how we handled the same thing in Delhi. I think all of you will agree that every city has come on a natural landmass, maybe centuries ago in some cases you had done when we had developed a new city. So developing a new city is much easier because you are starting with a clean slate. But when you are handling the same issue, that how the stormwater, which is the end result of the rainfall occurring on the landmass, how it will be evacuated from the area. So the natural river systems or the natural drains are doing that part when we are not disturbed that area. But when we are relaying the residential areas and then developing a city out of the landmass, we design those things with a master plan, master development plan, deciding that how much of that land will be urbanized, how much will be occupied by the residential areas. So defining a land use on top of that land mass. Why we are bringing the land use into picture, it has been mentioned by our friend Ramchandran also, that the fate of the rainfall on the land mass, which is in the form of the stormwater or runoff, how much of that will go into the soil, how much will be flowing over the surface, is dependent on the land use. So if you have concretized the area more and more, this we technically call runoff coefficient, that out of the total rainfall, how much percentage of that rainfall will get converted into stormwater. So that quantification is very important when we are talking in terms of the capacity of the drains to carry that water from those areas into some outfall points. So we thought that we must first of all, we must look at what is the carrying capacity of the storm drains as of now in Delhi. That's the starting point, because if the storm water is not getting carried, that means the drains are inadequate, they are overflowing the water, and then they are depositing that water or inundating the areas in the form of what we call flooding. So we also in the process found out many more things, that when we are looking at the drains of Delhi, you'll be surprised that I think I'll have some other figures also. Let me show you that the drains of Delhi are partially natural drains. And this was a question debated in the NGT when we started looking at the problems of the pollution of Yamuna, because we are trying to see that how much of the pollution goes into Yamuna and it goes through which areas. It goes through different locations, different localities. And we also found that all the natural drains of Delhi, they are flowing with sewage, with the wastewater throughout the year. Whereas technically they should be dry during the non-monsoon period because they are not supposed to carry the sewage. So a larger chunk of the capacity of the drains is occupied by the sewage because of various reasons. Maybe that the Delhi is not having the whole area covered with the sewerage network. That's a reality. And also many other localities which are unauthorized localities, they don't have the sewerage network. So all those things were part of the issue. So we started looking at those things, but along with that, we thought that Delhi was the first city which has been digitized. At that time, I'm talking of 2016 or 2015. And digitized means the whole data was available for all the infrastructure, including the terrain, including the drains and all those other aspects of the infrastructure of Delhi. We thought we'll use the latest technologies, the modeling effort, because models are the ones which can try to give you the answers to, because of the local conditions, what things you can expect on the basis of the local characterization. So we used all this data of the infrastructure, and we said that we'll generate scenarios. But I'll start with the fact that when you talk of the requirement of the drainage system, how you come to know that what should be the requirement, what should be its capacity. There's a question which is normally not understood by people in general. That's the starting point. So I'm showing here one basin of Delhi, which is the Barapulla Basin, which is the South Delhi area. It has all these, the drains which you are seeing, they're all part of the natural drains. Now, these many natural drains this system has, and each drain has its own catchment. That's where we don't understand, because each drain, it has its catchment in terms of when the rain falls on that area, which drain it contributes to. So that is what we call the catchment of that drain. Now, if we divide those catchments, you will get these many catchments which are contributing to various smaller drains of the Barapola. Now, this is one aspect, that how much area is contributing to the drain. Then which is the next aspect, and this is what is including the man-made drains, because when you are developed these localities, each locality needs a drainage network to really evacuate that area which is falling on the rooftop or which is coming into the roads and all other paved areas. And this is the a full view of the drainage of the Barapulla Basin. So then the next step is that to find out, after knowing that this is the area which is contributing to each drain, even the smaller, the man-made drains also you can include in those. Which is the next question, which is important, which most of the time people don't really get to understand, because when we say flooding, we only talk in qualitative terms. What is the cause of the flood? We don't answer that question. Which rainfall is the one which you want to cater the design to? Is it a rainfall which comes once in 5 years, once in 2 years, once in 10 years? So this is where the intensity of the rainfall, which is a function of what is the probability of its occurrence, that is normally missing. So if we don't get that answer, that means if the present system is designed for 1 in 5 year, it cannot cater to 1 in 10 year rainfall. It has to flood. I think that has to be understood, that if as a city you have decided that you want to cater to 1 in 5 year storm, then when it higher storm comes, when 1 in 10 year, 1 in 25 year, any higher storm is bound to flood some of the areas. So we must know that which category of rainfall which will flood which area in the city. That is where most of the developed countries, they already have their models. If you want to buy a piece of land, then you'll go to the municipality, you'll ask them that what is the probability of this area getting flooded? They will tell you using the models. So we need to reach that level where we have the quantification done, the level where we can assign the probability of flooding of a specific area. That's one part, provided you are not making any other changes. Whereas in our case, we are making changes not only to the local areas or the local drains, we are making changes to the Yamuna itself, the Yamuna floodplain we are encroaching. Now, you must have heard that Yamuna, this last year, it rose to 208.66 level at the Delhi Railway Bridge. And people somehow they use the relationship, the gauge discharge relationship, and they declared that Delhi has got 9 lakh cusecs of peak flood, which was wrong. When we analyzed that, we found that the flood level which has been attained this time is on account of some other extraneous factors, and the factors were encroachment, the siltation of one segment of the river, and that gives a misleading thing. And that is also very important to understand, that if we don't take care of the river in the proper manner, next time the same flow will come and it might go beyond 208.66, which means it might go above your embankments, and it will create a breach which will be flooding all your eastern areas, the East Jamna area, or even some parts of the western sides also. So I think since we have a problem of time, what we did, we used the models of various kinds. I'll show you that in the case of Delhi. Now, the urban hydrology models are those which mimics the local conditions which are urbanized areas, and it uses the hydrodynamic approach to find out that if the water has, this much water has entered the drain, how it is going to pass through the drain, whether it will be passing through the drain without overflowing the drain, or whether it will be overflowing the drain. Whereas the general hydrological models we use for peri-urban areas or rural areas, and in this particular case, we wanted to know, especially for the Nazafgarh basin, because Nazafgarh basin, a major part of the basin is beyond Delhi, is outside Delhi, is in Haryana. So we didn't have the data, but we wanted to know that when a rainstorm occurs in that basin, what is the kind of flow which will enter Delhi? To resolve that, we had to use the hydrological model to find out that for the same event, how much water will come into the Delhi through the Nazafgarh drain. And the SWMM model is the hydrodynamic, the urban model, which has been used. So I'll skip these things, that what kind of data we have used, and this I was mentioning that what is the extent of the drains, the man-made drains and the natural drains in Delhi, and there are a large number of 11 different departments are having the jurisdiction over these drains. There's another issue, that why we are not in a position to manage these drains properly. I was also mentioning that the sewage part, how much sewage is flowing into the drains of Delhi. There are different reasons. One, I had told that many of the areas are not sewered, so they are getting water. So 80% of that water is coming back, and that water is flowing into the drains. But we also found that there are many areas where the punctures, the sewer lines have been punctured because they got clogged, and then as a relief, local relief, that was punctured, and that sewage started flowing in the drain, and it was never repaired. So there are still some punctured sewer lines which have not been repaired, and that is one source of sewage coming into the drains in Delhi. And let me skip this also, because all this has been captured and we have already made it available to the government of Delhi, all the simulation frameworks. And I was mentioning to you the rainfall analysis. So that is the starting point where we develop the intensity, duration, frequency curves to identify that for a specific return period of rainfall, how much will be the. Yeah, here Delhi has two stations which we could get the data, 15 minutes interval data, and the 2-year return period and 5-year return period, the intensity of the rainfall is what we arrived at. And this has been used to work on the models that if this kind of rainfall occurs in this part of the Delhi, what will be the flow generated, and then how that flow, whether the existing drainage system is able to evacuate that volume of water without inundating the area. So we also went to the extent of sending our students to all parts of Delhi to capture what is the present status of these drains in Delhi. And this was done in the month of May. So you can assume that in that there was no rainfall, nothing of the sort. So I'm just going to quickly show you some of the drains, which is obviously, you can see that blackish water is there. This is, there's some problem that some of the figures are not coming. Anyway, yeah, I know. Yes. So I'll go to the next step, that what we did basically. We generated, Delhi government was very keen that we should give them a DPR, because they are used to, and that is one of the major issues that our urban local bodies, they don't have the capacity, or even the departments, they don't have the capacity to really use these latest technologies, despite the fact that we trained around 150 of their officials at IIT Delhi to tell them that what we had done, and then do the hand holding, that this is the way to generate the information so that you can evaluate that what is ailing a specific location. But we gave them, we said that this problem cannot be solved overnight. Let's try to pluck the low-hanging fruit first and try to see that what is the basic present capacity of these drains. That is one part. Then how we can reduce the flooding, assuming that we are catering to 1 in 5 year flood, 1 in 5 year storm. And using that, what is the situation? So we said that first of all, your drain should be totally clean of the solid waste, all the siltation which is there. Assuming that there is no siltation, how these will behave. So we created a simulation, and we found that even the 300 points they had given us, the perpetually flooded points, and the simulation also, they were flooding actually. So that was a good validation on our part. Then we said how we can reduce this flooding, assuming that 1 in 5 year flood is the one which is accepted by Delhi as accepted storm. The next, he said, let's use the additional water and rejuvenate the water bodies. So we connected, gave the connection that from where this will be connected to the water body, and how the water body, each water body will be having the overflow situation taken care of, and where it will go. All that was given as a second scenario, where we quantified that if you do that, how much a reduction in the flood volume will be there. Then the next one, which is quite easy to incorporate, is to do some rainwater harvesting. We also found in the process, which I think many people who are staying in Delhi, they will realize, that each locality, if you go to, there is no street level stormwater drainage there. So where your rooftop water is going? Can I ask that question? Where is your rooftop water going? No, is going into your sewer line. So everybody has got the rainwater, the stormwater, rooftop water connected to the sewer line, which is not designed for that. So with the result, there are many segments of sewer lines which get surcharged, which are supposed to flow on in gravity, under gravity. So they get surcharged, and then the manhole is oozing. The manhole is lifted up, and then you start getting the sewage flowing on the roads and the streets. So that is what is happening. So we thought that where this should go, if you stop that, remove those connections, where the rooftop water should go. We decided that let's have a line laid again in the maybe pipeline, and take that water to the nearest park. You have around 1,500 parks. Depress the park by 1 foot. Now that water will be the rainwater harvesting done, not at the household level, because it is not functional. Every household, whatever they had done, after 2 years is choked. So this will be a rainwater harvesting at no cost. And we showcased that how much will be the additional volume taken care of through this mechanism. So we then told the Delhi government that let's implement these things, and then let's evaluate that how much, and we can look at the specific locations where perpetually the flooding is taking place. Something can be done if there is an underpass, which people mentioned here. That underpass is because of the fact that the pump, when you have made an underpass, this is a low-lying area, now a depression, you have to have a pump station installed there. They have pumps, but it's never starting in time. So can you automate that process of pumping? And if you can do that, yeah, I think I'll finish here. I mean, I have sent my messages uh, because see, the 15 minutes is a very small time. We have showcased that how each place. We also found that there were some adverse slopes in some of the drains. Now, if there's adverse slope, obviously there will be a. So the idea of using these modeling approaches that you can see for yourself that what is happening in a very scientific manner, and that is what was done. So I think in the end, what we have said is that if this issue of flooding of the cities, whether it's Delhi or any other city, because all the other cities are also having similar problems, you have to very scientifically analyze why is happening and then find the solutions, which are basically not the big solutions, as Ramchandran was mentioning that here also there was a tendency of the ULBs to concretize all the drains. Even I think then there was an NGT order. I was asked to go and visit those drains, and the NGT had put a stop to that. That was what was done, and somehow it has not been taken for the other parts of the country. That's very important that the natural recharge, and the reason what they gave the South municipality, that why they are concretizing, I asked them. They said that sewage is flowing through that is polluting the groundwater. So I said, why the sewage is flowing through that? I mean, have you addressed that question that why the sewage is flowing? It's not a sewer line. It is a stormwater drain. So you should address that issue. And the NGT order of 2015 is basically that how you should, if you want to take care of the pollution of Yamuna, you have to look at the sources of pollution. And the order says that any sewage which is entering any of the natural drains, and Delhi has 201 segments of natural drains. If it is entering any natural drain, it should be intercepted there, not the final pour point, which we have made the big interceptor sewer. That is not the answer, because all these drainage systems, they have to be free of sewage. So I think I'll not take more of the time, but I feel that it requires the public participation. It requires people who are able to understand that what is their role. For example, this the thing that people have unknowingly, they have got there, because the plumber must have done that okay, he has connected to the sewer line. Nobody knew that what will be the implication of that. So we must use the science to, there's only one part which I am talking of, but I think as Dr. Kulkarni was mentioning, that everything is connected. I'm not mentioning another thing which we are doing in Delhi. We have another project where we are looking at the water security and sustainable development of Delhi and city of Delhi, which is a much bigger project, and where we have looked at all water systems, including the groundwater. We have come out with the quantification of the groundwater, how much groundwater is being used by Delhi, because nobody has answer to that. We're done indirectly using the groundwater modeling, analyzing the water supplied, analyzing how much is the sewage generated, and then many places the sewage generated is more than the water supplied. So that water is coming from the groundwater. This is very, very is possible, but not for everybody. So I feel that the capacity of these local water bodies, local urban bodies, to address these issues is very important, and we must lay the maximum emphasis on that. Technologies are there. We have people who can use all these technologies, but unless we take them along, unless we do the capacity building of these people, and they start using the models, as I was mentioning that in Australia, a person goes to the municipality and says that whether my plot which I'm going to take, is it prone to flooding or not? If it is prone to flooding, which level of flooding? Is it 1 in 10 years, 1 in 20 years? So I think that is where is doable, is all doable, but it has to have a proper system put in place, and all the people from different domains have to work together. Thank you much.
Thank you so much, Professor Gosai. And I mean, somehow we started little late this session, and we have not been able to make up, rather getting more and more late. So that's the problem. I mean, all the panelists needed much longer time with the kind of expertise you have. But I think I will request everyone to bear with us maybe a few minutes. I will request Pradeep Kumar Misra, program manager from CSE, to share some of the practical insights in his work. Be as quick as possible, 5 6 minutes, so that we don't. But we have a kind of 1 hour lunch break, so which is a reasonably long time. Normally, half an hour, 40 minutes also does. So I think I will bear with all of you to give a little bit. We are getting into your lunch time, but I think we had no other scope to curtail it, because instead of 11:30 plus, we started at 11:45, 11:50. So we tried to cut down every expert's time, but still could not manage within one. So Pradeep ji, please.
Thank you, sir. Very good afternoon to all of you. So in this part of the presentation, I will be talking about a study that we had done in the state of Uttar Pradesh. And thus the topic says that challenges in managing groundwater and lakes in the selected towns of the Indo-Gangetic Plains. So this study was done by me and my colleagues under the supervision of my unit head, Sushmita Sen Gupta ma'am. So before going into the detail of the study, I would like to give a small background that why this study has been done. So since morning we have been talking about different scenarios in urban areas. So I will categorize all those problems in three parts. On one hand, we know that because of this rapid rate of urbanization, there is a huge demand of water, and to meet that demand, the cities are extracting groundwater at a very high rate. So the groundwater is declining. That is one situation. On the second hand, we know that the urban sponges, the lakes and water bodies, they are being encroached. So their pondage area is also getting reduced. Thirdly, the rainwater, I mean the storm water is getting mixed with the sewage water, and that is flowing into these water bodies. So these water bodies, even after losing their pondage area, they are getting polluted. So these three situations are there, which forms the basis of our study. And for that, we chose the state of Uttar Pradesh. We have been engaged with this Uttar Pradesh for so long. And so this is the details of the survey and data that we collected from the state, from the four selected towns. The study was done between the months of August to November 2023. This time was chosen so that we could analyze the data in the monsoon period, in the post-monsoon period, and also in the dry periods. And we collected data on the demography, the hydrological data, meteorological data, and we also collected the lithological data and analyzed them. To analyze the groundwater levels, we collected the data of the piezometers, which was given to us by the state groundwater department and also Jal Nigam. And we surveyed some of the lakes and ponds in these four towns. Not only collecting the technical data, we also interacted with the community. We met many members, we did some household surveys. We had some group discussions to understand the perspective of the community on these issues. So this is the data that we had collected. We studied four towns, namely Jhansi, Banda, Rampur, and Raebareli. And in these towns, we had surveyed 165 wards. The number of piezometers that we studied is more than 200. We collected borehole logs, that is the litholog data for more than 100 borewells. And we surveyed 47 lakes and ponds. And this data was given by the departments that is mentioned here. And also we had conducted more than 20 focus group discussions with the community and more than 200 personal interviews. So this is the map showing the four towns located at different parts of the state. And this is the highlight of the challenges that we saw in these four towns. That the rainfall in the last one decade is declining. In the three towns, Jhansi, Banda, and Rampur, whereas in one town, Raebareli, the pattern of rainfall is a bit erratic. It is fluctuating. And we know that in some part of our country, we had good amount of wells which extracted water from these unconfined aquifers. In Banda and Jhansi, we saw that there were some old wells, but now they are getting dried up. And those wells which are dried up, they are used as a solid waste dumping sites. And because of this drying of the unconfined aquifers, now the water is being extracted from the deeper aquifers. And in Jhansi, we found that because of this huge amount of extraction, there is some issue of fluoride contamination in the groundwater. So I will show some photographs in the later part of presentation, which will better illustrate the situation. This is a table which shows the snapshot of the study that we had done. It contains the population of the towns, the area of the town, the total wards, and the wards that we had surveyed. The trend of the rainfall in the last 1 decade. We have seen that in most of the cases, the number of rainy days has also declined. And the state of groundwater, which is also in a declining state. The lakes and water bodies are either polluted or they are encroached from all sides. And we have also tried to calculate the rainwater potential, the annual rainwater harvesting potential in these towns. So this is the rainfall pattern of Jhansi for the last 1 decade. You can see that the annual rainfall is always less than the normal rainfall. And also there is a decrease in the number of rainy days. In 2013, it was 71 rainy days, while in 2023, it was 56. Almost same is the case with Rampur, although there is a slight increase, but in most of the cases, we have seen that the annual rainfall is always less than the normal rainfall. This is the rainfall pattern of Rampur, I think. I'm not able to see the. Okay, this is the this is Raebareli, and in the last 3 years, you can see that there is a decline in the rainfall. So, out of all the piezometers that we have studied, I have just tried to plot only 4 here. You can see that the state of groundwater is always in a declining state, and if we have also tried to plot one piezometer where there is a very slight increase. And this is with the Banda. You can see that, sorry, this is in the Rampur. In the Rampur, while plotting the data, we saw that there is a very slight increase in the groundwater levels. In Banda, the situation is very worse. You can see there is a steep decline. The trend line shows that the groundwater level is declining at a very high rate. Then in the Raebareli, the situation is again the same. So in every, except Rampur, in all the 3 towns, we saw that the groundwater is declining. After this groundwater, we come to the status of lakes and water bodies. In Jhansi, we studied 4 lakes, namely Lakshmital, Atiyatal, Pani Ki Dharmshala, and Lakshmikund. Out of this, Lakshmital is the biggest one, and you can see that there is a situation where a lot of solid waste dumping is there, and if we see the satellite imagery of Lakshmital, we can see that in 2012, the water spread area was around 36.6 hectares, while now this pondage area has been reduced to 22.6 hectares. So the size of the pond has reduced because of the encroachment. This is the situation of the drains. You can see in the photograph that these drains are clogged with the solid waste dumping. Also, there is a situation of mixing of grey water and black water, and ultimately this mixing of this grey and black water is entering into the water bodies. That is also polluting these water bodies. In Rampur, this is the situation of a pond in the police line that we had studied. There is a reduction in the pondage area. Initially, in 2011, it was 0.72 hectares, but now it has reduced to 0.4 hectares. These are some of the photographs of the lakes and the drains. Now you can see the raw sewage is entering into this first photograph. You can see this is a lake, and the raw sewage is entering into this lake. The drains are all clogged, and there is entrance of grey water into this pond and solid waste dumping. This is the scenario of the lakes and water bodies. Now in Banda also we had there are many ponds, but out of all of this we had studied 10 ponds, and this is one of the scenario in these ponds. In the Chabi Tala, we can see there is the gray water entering into this pond, and also there is a lot of solid waste dumping. This is the satellite imagery where we can see in 2013 the water spread area was as it is seen in the image, and it was around 2.87 hectares. But now the pondage area has been reduced, and also there is a lot of encroachment settlements around this lake. While talking about Harai Bareilly, a total of 30 ponds were surveyed, and most of them were either encroached from the all sides, or they were polluted. And while talking with the departments, we came to know that 2 ponds have been taken under AMRUT 2.0. But again, while talking about the restoration of lakes, what we found that most part of the money is being spent on the beautification part rather than improving the water quality. This is one famous Nazarwa Tal in Rai Bareilly, where you can see the wastewater from all those colonies enters in this lake, and there is a plan to revive this pond, but again the plan is mainly for the beautification, I mean strengthening of the bunds, etc.
पूरा summarize कर लें प्रदीप, because I think situation looks, the challenges looks very similar and condition looks similar in most of the places you have seen. Yeah, not only here, I think the problems are similar. Bangalore, almost similar, and then we are in the four relatively smaller towns in UP. We are seeing the similar kind of trend. The problem is, unless we give priority to the water body, this will happen. And then, as you very rightly said, that these schemes come. AMRUT 2.0 brought some sort of funding support for rejuvenation of water bodies, urban water bodies. But the thing is, as he told, as professors have told, I think the urban system or the officers or the ULV has to understand what exactly is the need of. I mean, you have to ask what the lake wants, not what the people around the lake wants. Someone may want an apartment to be constructed, someone may want a park, or someone may want a good view. So we basically bring some sort of a good compound wall, spend again more concrete. And so I think that's the challenge. I think what your project is very nicely documented and actually brought all those things. Hope this can be actually taken to the decision makers there, the municipal commissioners or the secretaries or the other people, to see that this is where your Jhansi or your Banda or your this town is changing. And at least now, can you do something to arrest it or change it or rejuvenate it? I think that should be the ultimate message to them. और बोलो, करी, you conclude.
Okay.
All these photos bring the same. All the photos are bringing similar stories. I mean, ideally, we were discussing with him. This is the subject and the kind of matter it requires. I think a half a day kind of workshop to go into detail of everything and open a kind of dialogue at every presentation for half an hour, 1 hour. Because I mean, the issues are really very intricate. And whether it is mixed flow, sewage, and storm water, and why it happens, I think each of them needs a huge kind of discussion. I mean, there's a lot of issues.
So I would like to just focus on this one town now in this slide. So we can see this is the map of Jhansi, and in this Jhansi town we have this northern, central, and western part all covered with the habitations. Now there should be some open spaces we can go for groundwater recharge and also for the construction of these lakes and water bodies, more number of water bodies. So here we, as a suggestion from our study, we can say that this eastern and the southern part, since we have these open spaces, we can construct more number of water bodies. And if there are some previous, they can be revived. And also in these institutions, like in government buildings, in colleges, in schools also, there should be a provision of rooftop rainwater harvesting. So this may serve the purpose that for the issues that we are talking about. So this is a summary of the analysis of the data that we had analyzed for all these 4 towns. That there is the decadal decrease in the rainfall as well as in the groundwater level. And there is a need to harvest rainwater as much as possible for all these towns. Even if today Rampur is seeing a small increase in groundwater, I would like to tell a situation. When we were surveying, when we were talking with the communities, we came to know that people are cultivating paddy 3 times a year using groundwater. So in summers, if you're using groundwater for the cultivation of paddy, we can we can imagine what the situation will be in future coming years, right? So this should be a part of the community awareness also, that we should change our cropping pattern. Instead of going for a paddy in summers, we can crop something else. And there should be a clear distinction between the storm water and the wastewater carrying drains. So these are the recommendations based on our study that we had done. There should be a database of all the lakes and water bodies, which is missing as of now. And the demarcation of lake boundary is very necessary. Because as from the satellite imagery, we have seen that the pondage area in the last 10 years, 10 or 15 years, it has significantly reduced. And we know that one solution cannot serve the purpose for all the problems. So there should be a menu, there should be a matrix of the technologies of the solutions, which can be implemented as per the site specific conditions. And there is of course a need of the capacity building of the stakeholders, those who are working in this sector. And there should be a clear schedule of the maintenance of these water bodies and lakes. So I would end my presentation with this slide. Thank you so much.
Thank you. Thank you so much. So finally, I think we are so much over time, so I don't think we can take any further discussion and all that, because I don't think we will be able to come back for lunch after lunch also for the next session. So I think, though I know I myself want to speak and cover a lot of things, all of you also have this thing. So are our distinguished experts. But I think in the interest of housekeeping, I think I will thank all of you and close the session. Great work being done by CSE. I only word will be have done some specific work. So I think some of these recommendations as a kind of thing you should not just give to some place academic things, should go to the municipal commissioners, the ULVs. At least you said this area you can do something. That area, see, something has done. It's not very easy for the municipal commissioner to change it, also knowing the dynamics of the ground situation. But they must know that okay, still you can save a lot, and where you can do it, how you can do it. So I think if this project gives that kind of direction, then at least we'll be taking some step in the right direction. So thank you once again, everyone. Bye.
So, as Sir said, we'll be cutting down on the lunchtime. Because our speakers have to leave for the flight. So we'll be sharp here at 2:05. I think 40 minutes of lunch is good enough. So 2:05 sharp, we'll start the session, next session. Thank you.
This was a very, very attentive.
Audience.
I mean, they didn't mind. Normally, 5-10 minutes late, also people get very restive, but they were.
So we have a very interesting.
Good enough.
Yeah.
Then very good. Actually, each can could have gone for about 1 hour each. I mean, ideally.
Thank you, Kulkarni sir. We'll be getting back again after post lunch, sir.
Yes, I tried to join. I try my best to join.